Okay.
No, you don't want to write that. This is painful.
I'm sorry, guys.
This is like... I'm going to resist the urge to throw your iPad across the room. You will not know what to do initially, and you need to have that tenacity and that determination, that motivation to just throw everything at it.
That's got to be correct, because like,
It's
I mean,
nice,
look at
isn't
it.
it?
It looks
Nice.
beautiful. Like International Physics Olympiad versus International Maths Olympiad. I'm here at Oxford University once again with Tom Rocks Maths. Thank you so much for having me.
My pleasure. My pleasure. I had a lot of fun solving a physics problem, so I'm very excited to do some maths.
I have a feeling that I'm about to be tortured again, but to be honest, I was really curious to have a look at what the International Maths Olympiad is like. I've solved quite a lot of IPho problems, and I've always really enjoyed them. They've always uncovered some really beautiful physics, and Tom has selected a problem from the International Maths Olympiad for me.
I have. I would say, I was about to say, sorry, that I tried to be nice and pick something physicsy, because you were very kind and gave me a fluid mechanics question, which is my area of research, and so it was, you know, and a course that I also teach. So I did enjoy that. But there's a problem. It's not just me, my fault.
Literally, yeah.
The International Math Olympiad, it's all basically pure maths. Right, there is no mechanics. It's all like number theory, geometry. In short, algebra. So, unfortunately,
Sorry, I have to run away.
yeah, I was like, you know, when you set me this challenge, I was like, oh great, I'll find a nice mechanicsy question. Don't exist. So the Maths Olympiad generally is focused on number theory, geometry, algebra questions, taken very similar to the Physics Olympiad, taken by high school students. So I think you were saying the students have to be under 20 and cannot be at university, we believe are the rules for the Olympiads. And the maths one, so you have, sounds quite similar to the physics one, you have the 3 questions, 4.5 hours to work through them. So we're just going to do one question. This is a medium difficulty, so there's sort of easy, medium, hard, is how they structure the 3. This would be question 2, so it would come under the medium difficulty category, but you would have a whole hour and a half try and puzzle your way through this. So I don't know if we're going to need the whole hour and a half.
Probably going to need more.
Yeah, I mean, I am here to be your mathematical genie to guide you and grant you your mathematical
I'll definitely
wishes.
need that.
Yeah. So I think between us, right, I've already had a little bit of a think about this problem. You, of course, have never seen it before. So I think between us, we can make some progress and hopefully get to the solution.
Let's have a look. So what do we have? So for all polynomials f with real coefficients such that for real ABC, such that AB plus BC plus CA is equal to 0, we have the following relations. F of A plus F of B, and I have not copied the whole problem. Sorry.
I think no, that is it. Yeah.
Is that it? Is that it?
That is it. Yeah.
Oh!
That is the whole problem. That's
Wait,
all you
what?
get. That's all you get. You've got...
So one of the things that I noticed is that, you know, when we did the physics problem, which is...
It's like 2 pages.
Channel, yeah. And that's just the introduction. That's not without actually giving you any of the problem. Whereas this is, it's about a line. I generally thought that I've not put in the whole problem.
No, that's it. You've got a condition, 2 conditions in short, right? You've got a condition on some numbers, right, A, B, and C, which we're going to play around with. And then you've got a condition that the polynomial f must satisfy. So by polynomial, of course, we're talking about powers of x. So it could be a quadratic, which would be, of course, highest power is x squared. Maybe we've got a quintic going up to x5. Okay. Maybe we go even higher. I don't, who knows, right? But it's saying we are looking for something that's going to be like powers of x. And it has to satisfy this relationship.
Having looked at some of the Maths Olympiad problems before, just for pure fun, I think 3 Blue 1 Brown has filmed a few of them. Actually.
Yes. Grant loves doing demonstrate because they are fantastic problems, right? They make you think. You have to use all kinds of creative problem-solving techniques to actually get somewhere with them.
Okay, so let's have a look at this problem. So find all polynomials with real coefficients. Okay, so they are real. That's good. That's a start. Such that AB plus C, we have the following relation. F of A minus B, B minus C is equal to that. So in reality, we've got at least 3 different variables, right?
Exactly. Yeah, good spot. So you're thinking like a mathematician. There's quite a lot of freedom, I would say, right? So you've got like I mean, you could think of it as saying there are two equations,
Well, this is
and you
probably
have three variables.
it's probably satisfied for the trivial case, right? Like when a, b, c is equal to 0, but that's probably not what the problem is after.
That would tell us something. What would that tell us, actually?
Would it tell us something? As in, if a is equal to b, which is equal to c, which is equal to 0, well, then we're going to get f of 0 plus f of 0 plus f of 0 is equal to 2f of 0, which seems pretty fine. Like,
That's interesting. So that does tell us something. What does it tell us?
does it?
It does tell us something, yeah?
Oh, does it tell us there is no constant term?
Exactly.
Out of
Yeah. It
polynomial,
tells us that f of 0 is
Oh,
0.
that's such
There
a
we go,
yes.
progress.
Yeah, there we go.
Nice.
Okay, yeah.
So yeah, it literally, right, you've got 3 lots of it on the left, 2 on the right, so it literally tells you f of 0 is 0, which is really good.
I feel like a proper mathematician now.
Yeah, that was good. That was good intuition, right? Like set them all to. So this is actually a really good technique. Is when you have lots of degrees of freedom, lots of variables, like you mentioned. Sometimes it's like too much, right? And you're like, how do I even begin to get anywhere with this? So you kind of like, at least I find a helpful way into these problems, impose like false constraints. So say to yourself, okay, well, what if they're all 0? So then our condition is still satisfied, right? The one of multiplying them and adding them. And then you sub it in and we've discovered something about f.
So I know, but I think I remember watching an interview with Terry Tao who was saying the way to approach problems is usually to think of the easiest subset of the general solution that you're potentially looking at.
That's what you're doing. You're like, well, what if they're all 0? Cool. We learned something.
Right.
Absolutely that, yeah.
So what's the next
easiest
solution? Well, I guess one of them is something, and then the other 2 are 0, and then it's going to be 2, and then hopefully all the way up to 3.
So let's say A is non-zero and B and C is 0. What does that tell us?
Okay.
Well, first of all, is the condition satisfied?
Is the condition satisfied? Well, let's have a look. So we can say that f of... Let's label the work a little bit better.
So that's called the actual equation. So I say the condition, I mean AB plus BC plus CA is 0.
Okay. So, well, let B is equal to C is equal to 0. Then we're going to have AB plus BC plus CA is equal to 0. And yeah, I mean, all of these terms contain a 0 term, so 0 is 0.
Don't write it. Oh, no. now you've written, that is very physics right there.
Is it? Okay.
No, you don't want to write that. You would. So the maths way, you'd say left-hand side equals 0 equals right-hand side. Because writing 0 equals 0 is just, it's just, please don't ever do that. I tell this to my students. You have to say the left-hand side is equal to this, and the right-hand side is equal to this. It's like showing they're equivalent.
But what's your beef with 0 is equal to 0 exactly?
You shouldn't write it because you could try and divide both sides.
Oh, yeah,
just you're going to get into a mess.
I did that totally on purpose.
It's fine. You're right though. It's true, right? It's a true statement. So that works. So then what happens for our actual equation about f? What can we learn about f?
So we're going to go f of a minus b, which is 0, plus f of b minus c, which is just 0.
Yep.
Should we just write this like that? Plus, actually, this whole thing is going to disappear because there's not going to be any constant terms, right? So this thing is just going to be 0.
Yep.
Then c minus a, c is 0, so that's going to be f of minus a is going to be equal to 2f. A plus b plus c is just going to turn into a, like so. Let's get rid of this one. So f of a plus f of minus a is equal to 2f of a. Yep. And even me as a non-mathematician can spot that we are going to be dealing with something like x squared or x to the power of 4, x to the power of 6, etc. Because, I mean, that... Well,
if you cancel an f of a, I think it becomes really clear. So if you subtract f of a from both sides, and then you've literally got
f of minus a is equal to f of a, which is a lovely symmetry to have, meaning that we're dealing with a even polynomial.
Yes, yes. So this is the definition of an even function. So we're like the full-on, if in maths you're saying such and such is an even function, this is what it means. So you can say, okay, f is even, and because it's a polynomial, that means you're only going to have even powers.
So we can have something like sort of x squared, x to the power of 4, x to the power of 6, x to the power of 8, potentially all the way up to x to the something, right?
2n.
2n, yeah.
Yeah.
Mathematicians.
Yeah, let's call it something. It's helpful to call it something.
2n. Okay. So which one of these are basically going to be our polynomial? Because our f is going to be sort of some coefficient x squared plus some coefficient x to the power of 4 plus some coefficient x to the power of 6 plus x to the power of 2n.
Exactly. Yes. Potentially it could be.
Potentially, right. So how do we decide? This is funny enough, this is actually reminding me slightly of the previous problem that you gave me. I think it was one of the math ones where we were also dealing with polynomials. And
Okay,
we're also
we do like our polynomials.
With powers of n as well.
Okay.
And I found that really difficult.
I had actually forgotten that we'd done that. I swear. Like this is I'm just you're making it seem as though I like watched back our video. I was like, what could he not do? Let's do it again. Like that is not how this went.
Sure. Yeah.
It's not how this went.
So how would you proceed with?
Well, you have
sort of case,
so you have some candidates. So what if you? I mean, again, you sort of gave yourself the answer earlier, right? Like the simplest subset of the possible solutions would be, well, what if f of x was x squared? Would that work? Because we have to find the most general possible one. So let's just try and find one that works, right? So what if it was just what if f of x was x squared? Would that work? Because we know that that fits with our calculation so far.
Well, if that's the case, then we could look at the general case of this condition here, right?
Yeah.
So we could probably say that a minus b squared.
Yep. So you're just going to sub it in, right? You're just saying, we've picked an f, let's try it, see what happens. So if f of x is x squared, f of a minus b is a minus b squared.
Plus b minus c squared plus c minus a. This is going to be really tedious for all the high cases, I think.
We probably don't want to do this for all of them. I will help you out with that. But I think doing it for 2 is helpful.
Okay. I think 2 I can probably manage. Probably, let's see. So it's going to be a plus b plus c, all of it squared.
Yes.
Okay, well, let's do a bit of expanding out.
Does it work? Right?
Yeah.
That's what we're trying to work out here.
Is something like Wolfram Alpha allowed in the International Maths Olympiad? Or
I would assume not. I honestly don't know. I would assume not.
No, I'm pretty sure I know the answer.
Yeah.
No calculators, no tables, nothing.
And we're going to set this out like a mathematician. So you're going to write left-hand side, LHS, equals...
Okay.
No, come on. We're doing this properly now. So left-hand side equals, and you're going to expand it out.
Okay.
And see if you get the same on the right.
A squared minus 2ab plus b squared plus b squared minus 2bc plus c squared. I feel like a ninja at expanding today. C squared minus 2ca. I'm probably going to do a mistake after I bragged. Plus a squared.
That's plus.
I knew it! That's a plus. Of course it's a plus.
Okay, so that's on left.
I was just testing him.
And then now I would say right-hand side equals, and you're going to hopefully argue that they're the same.
Okay.
So this one's going to be less fun to expand.
Yeah, there's a few different ways of doing it. I am just going to go basically this times that. I'm sure there's some sort of a formula or something that I'm missing.
I like it. It's less likely to make mistakes.
Famous last words. And that's not too bad. I'm just going to go a squared plus ab plus ac. A squared plus ab plus ac plus I'm going to write this as AB again.
Yep.
Plus B squared plus CB plus CA plus CB plus C squared. I think that's right. I've got an A squared, I've got a B squared, I've got a C squared, and I've got 2 sets of the other terms. I think that's fine.
Yep.
Okay, so question is, does this thing here on the left equal the other thing? So does the left-hand side equal the right-hand side, which hopefully we want for it to happen during an equation. Now, shall we just simplify it a little bit? Because I can see the 2a's and 2b's squared. So I have like 2 sets of a's here, like here and here.
Yep.
And then I've got like 2 sets of b squareds and 2 bits of c squared across here. So that's a good sign. Yep. So I can probably just go left-hand side is equal to 2a squared plus 2b squared plus 2c squared. What's left afterwards? I've got minus 2.
Yeah, I was going to say, take that factor out. Yeah, nice.
Plus BC plus CA, like that. That's about as far that I can see, but that seems really suspiciously close to the... Ooh, look at that.
It is the condition, right? Yeah. It's exactly the
AB
condition.
plus BC plus CA.
Mm-hmm.
Look at
That's
that
going to be
beauty.
0. Yeah.
I'm loving maths today.
Just today.
For now. No. You know what? I really love calculus and I really, really love applied maths, but I think I just find a lot of the pure stuff just a lot more difficult, which is potentially might be a common theme. I find it really interesting.
I mean, being a physicist, that would make sense, right? Because you're using the calculus and the applied stuff as a physicist. So it does make sense. It does make sense.
So basically this term can sort of go, right?
Yep. Yeah.
So the whole left-hand side is going to be equal to 2a squared plus 2b squared plus 2c squared.
Yep.
Okay, now let's see if we can... Oh, look at this. AB plus AC plus CA. It's an AB here.
Two ABs, 2 ACs, and 2 BCs.
That's fine. So the left-hand side is equal to the right-hand side because the right-hand side is going to be equal to a squared plus b squared plus c squared plus whatever that was. AB, is that a plus? Let's call it a plus.
Yeah.
Which is also going to disappear.
Yes, there's technically 2 lots of all of that, but it doesn't matter because it's 0.
I've kind of factorize it.
But there's 2 lots inside the bracket.
Oh.
It doesn't matter. It's still correct. Yes, there's an extra 2. Yeah. It's 0. I'm sorry. I'm calling you that 2 times 0 is still 0, right? It's all good, but yeah.
So
they perfectly match.
0 equals 0, right?
No, stop it. Oh God, this is painful.
I'm sorry, guys.
This is like... I'm going to resist the urge to throw your iPad across the room.
Okay, so we know that this function, whatever it is going to have some sort of a coefficient, call it A1 or C1 or whatever. Should we call it C1? I think that's the terminology we normally use in maths, right? So
I just probably call it A, but probably no, we shouldn't call it A because there's an A in the question.
Oh, right, yeah.
Call it whatever letter you want. Yes, I think.
Okay, so C1 x squared. I seem to remember from maths lectures we're typically using C1, C2.
It makes sense, yeah.
Yeah. So we know that's there. I don't really fancy expanding to x to the power of 4, but I guess we could.
You could. No, you're right. You could absolutely go in and say, does x to the 4 work in the same way? Does x to the 6 work, etc. But as you've realized, right, as you've established yourself by thinking about the problem, that is it's like there's too many cases, right? You're doing this by hand. I mean, given you had an hour and a half, you could totally try and go through and do this. But we're going to be smarter. I know you're now dying to do this, but we're going to be smarter about this, right? So, because again, even if 4 works, 6 works, maybe 8 doesn't work, there's too many to check because you would have to check every even power. So we do need to find a slightly simpler way to do this. So my suggestion, my idea to you again, think about what we did at the beginning. So we sort of said, what if they were all 0? And then what if one of them wasn't 0? In both cases, we learned something useful.
So
And then that allowed us to deduce that x squared is definitely there.
I think my problem is that the next sort of simplest case is probably they're all sort of, or like 2 of them are potentially, one of them is 0, then 2 of them are non-zero.
That could work. You'd have to be careful because we would still need to satisfy the condition. It would no longer be clearly 0 if only one of them is 0. But you could try and do that. But to sort of, I'm going to use myself as, I promise to be a mathematical genie. So being a mathematical genie, right? If you set b to be equal to x, so in other words, it's just any variable, right?
Right.
But we're just going to use x just to make it very clear it's a polynomial. Now, let's suppose we also want c to be kind of anything. So here, anything means a multiple of x.
Okay.
So pick your favorite letter that isn't A, B, or C times x.
ZX.
ZX. So physics, very good. Okay. I think that's confusing, but we'll go with it. Right. So
No,
at
shall
the
we,
moment...
shall we call it an alpha x?
No, you can do Z. We can totally do Z.
okay,
We can
okay,
totally do...
okay.
That's, you've committed to it. It's
Yeah.
fine. Okay. So C is ZX and Z is unknown.
Yeah.
Right. We have freedom to pick Z. And in theory, we had freedom to pick B, but we've sort of chosen its coefficient to be 1. Just to kind of... Again, we have like too many degrees of freedom. Now, if this is B and this is C, what happens when you sub this into our equation? That must be true.
Well, we know that this here has to be true. AB plus BC plus CA is equal to 0, right?
Yes.
So
if we've picked B and C, can we also pick A?
Yeah, we can, because it's just another, it's just the third variable, right?
It is, but we need this equation to be satisfied.
Yeah.
So you could rearrange this to get A in terms of B and C.
Oh, we can't really because it's
right, so you can't pick A.
Yeah.
Because we picked these two.
Yeah.
Right? Okay, I know we haven't yet determined what Z is, but because we've picked them...
So it's basically equal to that, right? Well,
you've got 2 A's on this side. So
oh, yeah, my bad. Yeah. I totally didn't do that. Oh, I did that.
You've got the right idea. We want to rearrange, right? We want to get A equals something. So let's see if we can...
okay, so A, B plus C is equal to minus BC. A is minus BC over B plus C, right?
Yes.
And B is minus X multiplied by ZX. Okay, so that's over B plus C, which is X plus ZX. So that is equal to minus ZX squared over X plus ZX Z plus 1, like that?
Yep. So we can cancel an X on the top and the bottom. So A is also linear in X, which is really nice.
Okay.
So what we've kind of done here, just to like recap, is we have 3 variables, but we have like 1 condition. So we picked 2 of them.
Yep.
And we've done it in such a way that we want one of them to have coefficient 1 and the other one can have any coefficient we want.
Yep.
Of course, we could have said these 2 have any coefficients we want, but then you'd just be considering the ratio of them. So all we've done is said b was equal to yx and then just divided through by y. It's fundamentally, it's the same thing. By making it 1, it just makes the algebra a bit nicer. So that's then fixed A. So what we've kind of got here is, rather than having 3 variables, which really was 2, we've reduced it down to a case of z is the only thing that we are free to pick. So now let's sub these choices of A, B, and C into our equation for f. And then what we're hoping is that might give us a clue or an insight to be like, oh, well, what should we pick z to be to make f equation look nice?
Okay, so would you put them into our condition for f in terms of some polynomial power n that we don't know? Or...
Just exactly as it's written. I think I would just leave it as f of something.
Okay.
So we want, it was f of, was it a minus b first? Yes.
Yeah, a minus b. Okay, so f of Okay, A, what did we pick?
A is the one over here.
Oh, right, of course. Minus zx over z plus 1. Okay, minus b, which is minus x. Then plus f of b minus c. X minus zx plus fc minus a. Zx minus minus a, so it's going to be a plus zx over z plus 1. And that's left hand side, just saying.
Oh no, now it's all just equal to, so we don't need to worry. We're not trying to show that two things are the same, right? So, but I like it. I feel like this is going to be the one thing you're going to take away from this, is mathematicians love left hand side.
You're going to see me in one of my videos in a couple of weeks going, oh, left hand side.
Totally.
Okay,
so this is now equal to 2 lots of f, a plus b plus c.
2 lots of f, a plus b plus c. Okay, so minus zx over z plus 1 plus b, which is x plus zx. Okay.
So it's a mess.
Yeah, I agree.
Right, but there is an important point to this. So x is just the variable, and x is on every term. So we're just going to ignore that.
Say that again, sorry.
So x is just like representing the fact that it's a polynomial. We could have just actually set x equals 1, and it would have, like, it wouldn't have actually mattered. The z is the interesting thing. So the point here is what we've got is an equation that previously contained a, b, and c and had a separate condition. We have now reduced it to we are allowed to pick z, and now the goal is, can we pick interesting values of z to learn stuff about f?
Well, minus 1 is probably not good, but we know that it has to be
you
even,
don't want z to, that's very good.
Yeah.
You do not want z to be minus 1, because then we're going to be doing all kinds of infinity stuff, and we don't want to, that's probably, it might help, but it's probably not going to help. But what other choices of z, because again, this is, it might feel like we're sort of, you know, if you're not used to this type of problem, it might feel like we haven't made progress. And that's potentially true, but what we've just done...
Pretty much how I feel, folks, but...
Well, okay, there will be some people watching, I think, hopefully, who will see where we're going. So, again, we started with, like, too many degrees of freedom.
Yeah.
And so we've just tried to say, okay, well, what if one of them was just 1? What if the other one satisfied the equation? And we're just trying to get it to it, because now all we have to worry about is let's try a few different z's and see what we can learn about f. That's kind of where we're at. I hope that's...
Probably the obvious choice is that, well, I'm not sure if it's obvious. I'm not sure if that's even going to bring us anywhere, but if x minus zx, if x is equal to minus zx, then the whole thing will, if x minus zx is equal to 0, then this whole thing will disappear, which...
so z is 1.
So z is 1.
So let's try that. I don't know if this is going to help, but let's see.
What if z is equal to 1? Okay, right. Well... Shall we see? So we're going to have x over 2 minus x on here. We're going to have a 0, which is just going to be 0.
So this is going to be, this is going to be minus 2x over
Sure, just write it down.
2. So minus x, f of minus 2x, I think.
F of minus 2x.
Yes.
Yeah.
Plus f of 0. But we know what f of 0 is.
Which is... 0.
We worked that one out, yeah. So that whole thing vanishes, yeah. And then that one's going to be...
Hang on, is my mental maths bad? So isn't that x over 2? Because z is equal to 1, so that's equal to x over...
But there's, sorry. Yes, I thought that was a 2.
Yeah.
Your z's look like 2s. No, this is me being an idiot. Your z's look like 2s. Sorry, yes.
No, that is a general... Like, my z's are not very good.
So it's minus
Interesting
x.
name of a channel, though.
Minus x over 2 minus another x, so it's minus 3x over 2. Right, yeah.
Minus 3x over 2.
Yeah.
Okay,
plus 0.
Plus 0. Okay, plus zx, which is
x.
f of x plus zx. Yeah.
So 3x over 2.
3x over 2.
Cool.
Oh, okay. Right. We're getting somewhere.
Maybe. I'm worried this might just give us what we already have, but let's see.
Oh, that's because these two just cancelled, don't they? Oh wait, pretend maybe not actually, because f of
That's
a.
a good point.
Yeah, yeah. So I don't think this is gonna.
I don't think this is going to tell us it, but let's see. And then what's the last one going to be?
Um,
3 over 2x, I think.
yeah.
Yeah, so it's just telling us that f of minus 3x over 2 is equal to f of 3x over 2. You're right, it's just reduced back. That's an x.
Oh yeah. Is that an x?
Yes, because that's x plus z times
Oh
x.
yeah.
It's confusing. Z is the thing that's equal to 1.
That's my fault.
It got me. It's all good, right? So you're right. We actually haven't learned anything, but it was a good choice. I'm with you that it could have been a helpful thing.
He's polite. He's very polite.
Okay, so we wanted to. So we tried 1. We tried -1. What else might we want to try?
Well, let's have a look at the. Let's try and be smart about it. Zx z plus 1 minus x f.
I was about to say we could try 0. What happens when we do 0? We literally get the same thing. We get the evenness again.
What if we make that side sort of disappear, sort of minus zx z plus basically this whole thing to equal to 0? Would that like
Maybe. What would that
zx
require us?
over z plus 1 minus x is equal to 0? They do look like 2's. Okay, so what would that give us?
Well, we can cancel the x, because x can be anything in a polynomial, right? So it's -1. So it's minus z over z plus 1 equals 1. Taking that one across, right? I think that's what we've got. So minus z equals z plus 1. I don't think it's possible. Or maybe it is. Minus 2z is... Oh, yeah, okay, we're going to get somewhere. Okay. Interesting. So z is minus a half. Okay, well, what's that do to the other ones? So that one's 0.
Sorry. Which one's 0?
That one's 0, because we set that one to be 0, didn't we? The next one is going to be 3 over 2x.
I might need more than an hour and a half, guys.
So let's try subbing in, right? Let's just sub in z is minus a half. See what happens.
Okay, like into here.
Into this one.
Okay.
This whole equation.
So, should we just change color? Right, I'm just going to do it up here. For z is equal to minus half. What are we going to have? We're going to have f of x over 2 over minus half plus 1 is a half. So that's just going to be x. Well, that thing is just 0, isn't it? Because that's what so I can just write f of 0.
Which we also know is 0, which is great. But yeah.
Okay.
Yep.
Plus f of x minus zx. So it's going to be x plus a half. X, which is 3/2 x.
Yep.
3 over 2x. Plus f of x plus 2x. Or x plus zx. X plus...
Is that not zx plus?
Yeah. Oh, that's a z, yeah. Gosh, my handwriting. Minus a half. Minus x over 2.
Yep.
Plus, why do I keep doing that? Plus zx, which is minus that, over a half.
Minus 3 over 2.
Minus, yeah. Oh, that's that thing. That thing is just equal to 0.
Yeah.
It's going to be a fun edit. Plus f of 3 over 2x. Maybe that will get us somewhere. Plus f of minus 3 over 2x.
And then what's the right-hand side?
Okay. That whole thing is equal to... I'm just going to do it over here.
So you worked that one out earlier and was equal to just x. Yeah. So it was a half over a half. Yeah, so it's just x. So that one's x plus 2x. Ooh. No, plus zx. Keep thinking that's a 2. Plus zx, so minus a half x. So it's 3 over 2x. Okay, we're back where we were. Great. Okay, so that told us nothing. We once again learned that f is even.
You know what? I'm really enjoying the fact that I'm just kind of like picking values to try and kind of, it's almost like getting like a data point to try and sort of understand the behavior a little bit.
It's exactly that. So you actually, so this was the obvious one to make 0. And then we tried this one being 0. I'm going to hazard a guess, if we made this one 0, you'd also get that it was even. It feels like there's a pattern there, right? If we were doing this in the full hour and a half, you'd probably just triple check that that was the case. So what I might suggest is, rather than trying to set these to be f of 0, on the right-hand side, we've got 2 lots of f. So on the left, what if we made, for example, the first 2 equal? So then we could say this is 2 lots of f of something and see if that helped. Right? Okay. So you're sort of saying these first 2, this is f of some function of x plus f of some other function of x. What if they were the same thing?
Ooh, that's exciting. Let's see.
Yeah,
let's calculate. Okay, so
at least that's, to me, that feels like once you've tried making everything 0 and learned some stuff, but again, not telling us anything new, the next step is, well, what if a couple of things were equal to each other?
Okay.
At least to me, that feels like where I would go next with this problem.
So what if minus zx over z plus 1 minus x is equal to x minus zx?
Yeah. We could, of course, try any pair, but let's just try the first 2 and see if we get anything helpful.
Okay. Well, minus zx over z. I'm just going to put like a little thing here.
That's how I write z's. I'm glad. This was giving me anxiety watching you not do that and me think they were 2s. Okay, this is... I'm going to breathe a sigh of relief. That now it's clearer to me they are z's. Okay, good.
Minus x... wait, what am I doing? I'm just rewriting this. So let's set that equal to 2x minus zx. So I probably just want to...
Now we definitely need a line. You've got a 2 in there. They look identical.
Yeah.
Like,
Sorry,
no. Just
no.
Now we have a 2. We definitely
that was
need
actually
a
a mistake because that was yeah.
Okay.
Okay. So
you're gonna have to multiply up by z plus 1 probably. Cancel the x.
Yeah, let's cancel.
Throw away the x again. We're just kind of carrying that. Again, we probably could have just ignored it at the beginning, but I just felt it would be helpful to include, to emphasize it's a polynomial. That's all. Right. Yeah. Feels like we're getting somewhere now.
Is that right?
No. I think you did something wrong when you multiplied up. We've got 2 minus z times z plus 1.
Ah, yeah.
Right, I think you just have to actually multiply out the brackets.
It's just the pressure.
You can pretend you didn't do that, it's fine.
It's the pressure of entertaining this wide audience on YouTube. So it's minus z is equal to 2 minus z
times z plus 1, yeah.
Z plus 1. Like that. Minus z is equal to 2z. 2z plus 2 minus z squared minus z. Like that.
Yep.
Minus z and minus z kind of go. So we've got 0 is 2z plus 2 minus z squared.
Yep. I'd probably multiply by -1, just so we can get a nice quadratic for z. With a positive coefficient. Looks nicer, doesn't it?
I agree.
I'll put it on the other side.
Z squared minus 2z minus 2 is equal to 0.
Right, so what are the solutions for z? To make those
Okay.
first two... This might not actually get us anywhere, but we've got something different. Z is clearly not a value we've tried, right? Like, it's not 0, it's not 1, it's not -1/2. It's going to be something else.
Okay, well, this here is a quadratic. Is this factorizable? Probably. No? Do I have to use a quadratic?
Formula time. How's your quadratic form? Surely physicists know the quadratic
I love
formula.
the quadratic formula.
Okay, good, yeah. Yeah, no, you're going to have to quadratic formula it. Doesn't factorize nicely, annoyingly.
All right. I was trying to factorize it in my head, but yeah, no. Okay, so Z1, let me just do that here. Z1, 2 is equal to minus B, which is going to be plus 2 plus or minus square root of B squared, which is 4, minus B squared minus 4AC minus 4A times C, which is 2.
-2. Becomes a plus.
Oh, yeah. Thank you.
Otherwise, you're going to get complex numbers, and we don't want that. could have happened, but we have to have real A, B, and C. And of course, Z is basically representing C here.
Divided by 2A, which is just 2.
Yep.
Okay, so this means that this here is going to be 1 plus or minus the square root of 4 plus 8, which is root 12 over 2. So there's going to be 2 roots, right?
You can simplify that third as well.
Yeah,
Pull
exactly.
out,
Yeah.
Just get rid of that 2.
1 plus root 12 is going to be 4 times 3, so root 4 is just 2, so 1 plus root 3.
Yeah.
Oh, that's got to be correct, because like,
It's
let
nice,
me look
isn't
at it.
It is
It looks
nice.
beautiful. Like,
So that's 1, or it could be a minus root 3 as well.
Yeah.
Of course.
We've
So let's go with root 3, right?
Okay.
Because again, we have freedom to pick Z. So if Z is 1 plus root 3, now we just need to figure out what the 3 brackets are going to look like, don't we? So we had, this was to make the first and the second equal. So just work with this one, it's probably easier. So if this is now x minus zx.
Oh, I can see some stuff potentially cancelling. X minus x minus root 3. Ah.
So it's just root 3x. Minus root 3.
Yeah. You had me questioning there.
So the first 2 terms are equal to this. Because that's what we picked.
Yeah.
So like going back to our big equation for f, you've got 2 lots of
So 2 times f
minus root 3x. And now we just need to work out what this third term is, which we have no idea what it is. So let's go back and see. What's this next one? This one, right?
It's clear as
Zx plus Zx over Z plus 1. I'll remember it. Zx plus Zx over Z plus 1. Right. And of course, we know what Z is. So what's that going to be?
1 plus root 3. I'm in the zone, folks. I'm ready to
Wow,
talk.
no,
on
this
it.
is-
It's exciting. 1 plus root 3. I'm just about to make a mistake, probably. 1 plus, okay. So that's x plus root 3x. Let's just write it like that. Did I work that out before? Probably not. 1 plus root, well, doing the same thing. X plus root 3x over 1 is over 2 plus root 3, like that.
So we're going to have to do some annoying simplification. And this might not even help us. Right? We're just, who knows, right? Who actually, like we're just trying things at this point. But let's see if we get something helpful.
Motivational words.
Yeah, I'm just, this is why you have an hour and a half. You just got to keep trying these things, right? And eventually we're hopefully going to get something informative about F.
Well, we can sort of factorize an x. Will that help at all, though? That is the question.
Well, how are we going to get rid of the third on the bottom?
The square root. Well, I could rationalize potentially.
Yep, I would recommend rationalizing, I think.
Okay. Plus x plus root 3x times by 2 minus root 3 over...
The bracket on the x plus root 3x.
Yeah.
Another annoying double bracket.
Yeah. Over, it's the difference of squares, so 2 plus root 3, which is going to be 4, minus 3, isn't it? Like that.
Just 1.
Which is just 1.
So there's no denominator.
Right.
That's why I was like,
Ah.
I could see that was going to help.
See, the stuff professional mathematicians spot.
Yeah.
Whereas us mere mortals, we just, we follow.
I just knew the bottom was going to be 1. That was all. That was, I just, yeah.
2f minus root 3x plus f x plus root 3x plus, okay, that bit's 1 x plus root 3x. Okay, now we've got a common factor here, so we could simplify this potentially even further. Question is that necessary?
That would help, actually, yeah. Now you've said that, I think that would help. Maybe. Well, either way, you're going to have to do some algebra. I like your commitment to actually writing out the entire line. I don't know if this is a physics thing or a maths thing, but I would literally just be like, right here, what this is equal to.
I think this is just a me thing for some reason.
Okay, no, it's commitment. I just get so fed up of writing the same thing.
Okay, so let's take this as x plus root 3x, and then we're going to have 1 plus, what's left here is 2 minus root 3, which is going to be 3 minus root 3 in total, right? Unless I've made a mistake somewhere.
Mm-hmm.
Oh, there's a minus 3x here, minus root 3x here.
No, that's right, yeah. 1
How's that
minus root
help?
3, that's right. So 3 minus root 3, yeah. You're going to have to expand out.
This whole thing?
Yep.
Great. Okay, 3x plus 3 root 3x, okay, minus, hang on, this times, times that, did I do that right?
Minus root 3x.
Yeah. It's like this, isn't it? Yeah, minus 3 root x like that.
3x plus that one minus root 3x.
Oh yeah, minus root 3x.
And then minus 3x. Not 3 root 3, it's 2 root 3s. So that should just be 3x.
Oh, yeah, my bad. Sorry, my brain my brain went blank for a second. Let me just double check that. So 3x is here, minus root 3x, okay. What have I done here? 3x minus root 3x. This times that is 3 root 3 multiplied by x minus 3x.
Yep.
Like that, okay.
So you lose the 3x term.
I do, yeah.
And then you've got 3 root 3 minus a root 3.
Oh, okay. That's just going to be like a 2 in there, isn't it?
Yep, 2 root 3x.
Oh, wait, hang on. Well, no, because I think I messed up with the signs here, right?
No, I think that's right. I think it's right. You should get 2 root 3x.
Oh, yeah, of course, yeah. 2 root 3x.
So that's the left-hand side. We've got one last term, which is the right-hand side.
Okay.
So that's the left of our expression, and the right-hand side was 2 lots of
A plus B plus C.
f of yes, which we wrote up here in terms of z's, didn't we? No, I think it is actually all the way up. Long way ago. Long time ago. This one, that mess.
Yeah. Minus zx over z plus 1. Minus zx over z plus 1. Plus x plus zx. plus zx plus, do you remember the last bit?
X.
Okay.
And there's also 2 outside.
Yep.
Right, so now you've got sub in z, which is 1 plus root 3, and do a whole load of other algebra. So fun, right? So fun. Apparently we like this in maths.
1 plus root 3, right?
Yes.
Minus 1 plus root 3 multiplied by x. Okay, so let's just do it the smart way. I'm not sure if that is
There's an
smart.
x everywhere, so you could just ignore the x until the end, almost.
Oh, right, okay.
Would be how I would think about it. But...
Okay. So minus 1 plus root 3 brackets over 1 plus root 3, which is 2 plus root 3.
Now you did work that out earlier. Sorry,
Yeah.
I'm just reminding myself because we did it there.
Mm-hmm.
We did zx over z plus 1 without the minus.
Mm-hmm.
Oh, plus zx. Okay, we can use simplification here, can't we? No, we can't. Oh, God damn it. No, because you factored in that term. Oh, you made it hard if you're... Okay, fine. I thought we could use a shortcut, but you did some odd factorizing that I don't think means it's as helpful as it could be. Anyway.
You know what? I was thinking about the title of this video, and I was gonna say I'm not gonna have any like torture in the title, but I think I'm changing my mind.
It's just like 4 hours of algebra at this point, isn't it? And we don't even know if it's gonna help.
This better help.
Plus 1. And then just plus 1 more.
Oh yeah, plus 1. Okay.
Right. You just got to work that out.
Yeah. Right, now I've got the joy of doing a bit of algebra. Well, arithmetic, excuse me, yeah?
He says as though we haven't just spent the last hour doing algebra.
X, oh gosh. If only there was a professional mathematician to help me evaluate this.
I mean, I could, but I feel like you need... This is you. I don't want to steal your thunder.
Yeah.
Right? This is... I will check and make sure what you're doing is sensible, but this is all you. This is all you.
So 1 plus root 3 over... Let's just deal with this one
Well,
later.
we already know the denominator is going to be 1 when we rationalize.
Oh, yeah.
Right? We can remember that.
Mm-hmm.
So you just got to expand out the top.
Okay, so 1 plus root 3, and then what do we multiply it by? To rationalize, we multiply it by 2 minus root 3, like that.
Exactly. And the bottom's just 1, so easy.
Very nice. Very useful to have a mathematician around.
We have our uses. They may be few and far between, but we have... They are non-zero. We have a non-zero set of uses. Right, so you've got to expand that out, and hopefully we're going to get something helpful. I'm feeling confident, though. Okay. I feel like this looks different enough to what we've had that I think we're going to get some new information.
Minus 1 plus... Okay. I think I'm just going to expand this and see what happens.
Yep.
So 2 minus root 3 plus 2 times root 3 minus... After all this work, I feel so slow at the very basic tasks. Minus 3.
Yep.
Plus 2 plus root 3, like that. Okay, 2 minus root 2. Okay.
You've got a 2 minus a 3.
Mm-hmm. So that's going to be plus root 3.
And you've got 2 minus 3, which is minus 1.
Was that sorry?
Never mind.
Yeah.
I'm skipping ahead.
What do I have so many extra brackets here? Oh, because there was a minus sign here. That's why. Okay. Plus 2 plus root 3, which is equal to 2f of x. Yeah, the minus 2s are going to cancel. This here is going to be a minus root 3 plus 3. This is cancelled. Ah, wait. Well, 3x.
Yep.
Okay, this
I
seems
think
like
we've got something here,
like
haven't we?
something sensible. I've no
Well-
idea how it relates to a problem. I've forgotten what the problem was, to be honest.
Don't worry. This is why I'm here. Right. I think we do have. So we have something new. Right.
Okay.
This is the key thing because before, when you were trying those to set each bracket to 0, we just kept getting the function is even. The function is even, which is reassuring, but wasn't giving us. So now I think we might have new information.
Right.
Because we've got this is the right, and then we've got these two for the left. So maybe let's write that out as one equation, and then we can try some values.
Okay.
Right. So I think the reason this is going to help us is we've got lots of 2s and lots of 3s. So at the moment, you had this really helpful idea earlier when we'd worked out even powers, and you were like, let's suppose our function, our polynomial, you input x, you output x squared. So now, let's suppose we input something, let's just call it y, just because we've used x. So, right, and then you output y to the 2n.
Okay.
So we're going to like generalize the process you did earlier. So if my polynomial, right, so the highest power that's in it is 2n for some n,
Okay.
because we know it's even. So let's see which values of n might work. So what you want to do is say this is f of thing, but now what we want to do is take thing to the power 2n.
Okay. I'm a little bit lost. I'm not going to lie.
Okay.
Yeah.
So if I can.
Yeah, of course, please.
Okay.
Yes, finally.
I think you're so close to figuring this out, right?
Okay.
So before we sort of said, well, what we said, suppose, right? We were like, suppose f of x was x squared. Right. So now I'm saying, well, let's just say, okay, so suppose f of x is now just x to the 2n. Right.
Oh, okay.
And we want to see which n work. Right. We know n is 1 works because you showed that. But now we could check n equals 2, n equals 3, n equals 4. We've still got an infinite number to check, but I have a feeling we're going to get something much easier here. So this is now playing the role of x. So if we sub that in.
Oh, so as in minus root 3 of x raised to the
power
2n.
2n, exactly.
Okay, yeah.
So that's what
Yeah,
f
I'm
is
with
doing.
you,
F
yeah.
is whatever the argument is, f just takes the whole thing to the 2n. Yep. And there's a 2 here outside, remember, as well.
Oh, yeah. So that 2 should be carried on.
This one doesn't have a 2, so this is the 2's inside here.
Inside, yeah. Root 3x raised to the power of 2n is equal to, well...
Single 2.
Oh, yeah, again.
3x to the 2n. 3x all to the 2n.
3x. Yeah, all of this is to
Not the 2.
Not the 2. Oh, yeah, of course, because that's
2's
outside, yeah.
Be a bit careful. But I think this is going to actually give us what we want. So now you say, okay, so we've got x to the 2n, x to the 2n, x to the 2n, so the coefficients have to be equal.
Yeah, yeah. So this, well, okay, so...
Because they've all got the same power of x. So you've got on the left-hand side, you've got some amount of x to the 2n.
So can I set minus root 3x to be equal to this to be equal to that?
They're not all equal, but what you could do is, I mean, maybe it's easier to expand out first. I'm probably jumping a step. So let's do, what is minus root 3 to the 2n? What does that give us?
Well, that gives us this thing squared to 2n.
So we lose the minus.
Yep. Oh, okay, yeah.
We lose the root 3. It's just 3 to the n.
X to the n.
X to the 2n.
X to the 2n.
And there's still a 2 from that
Of course,
one.
yeah.
That's fine. But so the minus goes and the square root goes, right? Same thing. So now we've got to do 2 to the 2n, which implies as 4 to the n. Root 3 to the 2n gives us...
3 to the n.
Yep, good. And then x to the 2n. And those two added together must now equal...
2, 9 to the n. 3 squared, yeah.
X to the 2n.
X to 2n, okay.
Now this is true for all choices of x.
Okay.
right? Because x is anything.
Mhm.
So what this is telling you is you've got some amount of x to the 2n here. So you could factor out x to the 2n is equal to this amount of x to the 2n. So you've got like
Okay.
2 3 to the n plus 4n 3 to the n has to equal 2 9 to the n.
So we could probably figure out what n is.
Exactly.
All right.
Exactly. I think. Yeah. So I think we've kind of turned it into, it's no longer a problem in polynomials. It's a problem in numbers, and numbers are a bit easier to work with.
Yeah. Yeah. I agree. Okay. So x to the 2n, and that's going to give me 2 times 3 to the n.
Yep.
Plus 4n times 3 to the n.
Yep.
Is going to be equal to just 2 times 9n x to the 2n, right?
And then just throw away x to the 2n.
Yeah.
There we go.
So now we...
So you can simplify this a little bit as well, because you've got a common term.
Oh, just 3 to the n. What is that? 2 plus 4 to the power of n.
Yep.
Is equal to... Can I just do 3 to the n? I don't know.
3 to the n.
Yeah.
Wait, I have to think about this. Because you had it here. This was 3 to the n times 3 to the n. So it's just 2, 3 to the n.
Was that, sorry? Oh.
So here, before you turn it into a 9,
yeah.
this was 3 to the n multiplied by 3 to the n. So you're cancelling one of them. So this is now just a single.
Oh, yeah. Ooh, very nice.
Oh, sorry, having cancelled it. 3 to the n times another 3 to the n. My bad. And now cancel one on each side.
Okay, yeah, of course, yeah.
So finally now, this is what needs to be satisfied. 2 plus 4 to the n must equal...
That looks like it's it.
2 plus 4 to the power of n must equal 2 multiplied by 3 to the power of n. And for whatever values of n this is true, where n has to be an integer because it's the power of x. For whatever values of n this is true, they're allowed in our polynomial. So you should check, for sanity purposes, we think it should work when n is 1, because you did this earlier.
Yeah.
So is this a true equation when n is 1?
Well, we get 2 plus 4 is equal to 2 times 3, which is fine, yeah, because that's just 6 and that's just equal to 6. So this here works. Left-hand side is equal to right-hand side, as one would say, yeah.
Okay, so again, we already knew that, but it's a good sanity check that our new rule is actually sensible. Okay, so the next one to try would be n equals 2.
A lot of checking in the International Math Olympiad, it seems. Okay, so that's going to be 2 plus 4 squared, which is 16, which is 18. That's going to be equal to 2 times 9, which is also 18. So that also works.
Right. What about if n is 3?
Ah, okay. I can tell that...
It's kind of like where we were earlier. But this is easier. Okay, there's a lot of work to get this rule, but it was easier to check than expanding out squareds to the 4s, to the 6s, to the 8s. And hopefully, we're going to be able to argue why this will fail later. Hopefully.
2 plus 4r cubed. What is that equal to? 4 cubed. My brain is fried. 16 times 4, 48, 50. Right,
64.
Oh.
16 times 4 is 60. You did 60 times 3. So 60 on the left. So that's 60.
Yeah, 60, yeah.
And on the right, we've got 2 times 27. 2 times 3 cubed, which is
54.
So it does not work. So n equals 3 fails. Right.
Okay, so we've got a fail. Question is, is that the only fail, though?
Well, what about if n equals 4?
I was hoping that you're going to find a general rule so I don't have to check.
Well, you can. No, you can. But we need to, there's something important we have to spot.
Okay. So...
Well, there's something you have to spot.
Damn it. If n is equal to 4, okay, 2 plus 4 to the power of 4, is that equal to 2 times 3 to the power of 4? Is there any clever way of checking that? Probably not. Well,
So 3 to the power 4 is 81, times 2 is 162.
I can tell
now-
your countdown training, by the way.
Yeah, no. And we didn't even do powers. And then on the left, you've got, what have you got? You've got 4 to the 4, so that's 64 times 4. Way too big.
Yeah.
Right, so it doesn't work.
It doesn't work.
So the first two worked. The third one, the left was a little bit too big. The fourth one, the left was much too big. The next one's going to be 4 to the 5.
Well, n is going to be like the dominant term, right? Because this one is 4 to the n.
Exactly.
And this one here is...
Exactly.
3
So you
to
can
the n.
basically ignore the 2.
Okay.
Right, so I agree. So as long as n is big, you can say this equation is basically 4 to the n is approximately 2 times 3 to the n. Like, just throw away the 2. Like, who cares about the plus 2, right? For n is big, yeah. N is big. It's basically 4 to the n is equal to 2 times 3 to the n. So, there's a few different ways of looking at this, but I would suggest what you can do is actually group the n terms together. So I would take the 4 across and then divide by the 2. So you say a half is approximately equal to 3/4 to the n. Right, and so the point is now, as n gets bigger, what happens to the right-hand side?
It gets smaller and smaller and smaller.
Right.
Yeah.
So we've shown it fails for 3 and 4. So as n, and this is approximately what we need to be true. So as n gets bigger, the right-hand side is just going to be even smaller. So it's just not possible. So that's your, like, it's hand wavy. This is how I thought about it. It's your, like, proof. Like, you could plot the graph of these two and show that it's not going to intersect. So you've got, right, so the original equation works. You argue as long as n is sufficiently big, it's basically as long as n is bigger than 2, this is actually what you need to be true.
So the only cases that actually sort of we're just kind of stepping out to into the big picture is going to be n is equal to 1.
Yep.
2.
That's it.
All right, because 3 didn't work.
Yeah.
All right, okay.
So what's f look like? To come full circle, we've got that.
It was x to the 2n, so x squared and x to the power 4.
Yeah, so keep putting the constants in. Let's finish the question in style. So putting the constants in.
F is going to be
all polynomials
C1,
have the form C1x4 plus C2.
Final step. X squared.
I think that's right.
That's
So,
amazing.
So
Wow.
That's it. That's it. So we got very early. It had to be even powers, right? You checked x squared explicitly. Again, you could have checked x to the 4 explicitly. It would have worked. Right, I know you wanted to do that, but I knew there was lots of algebra to come. So,
You know what? I have to be honest, because when Tom said that he could coach me for an IMO problem, initially I doubt him, and I was fully expecting for me to just, relinquish responsibility of the problem in a way, and have the video of him explaining the problem. So I'm just a testament of what a good teacher he actually is. So yeah, everyone get studying to Oxford University and Cambridge.
well, thank you.
Yeah.
I think also a round of applause for the student here. Like, you did very well
Thank you.
to sort of follow along, because there's a lot of like tricky concepts in that, right? I think I would say for me the main takeaway, having tackled this myself as well, you just have to, like we saw this, right? You just have to like restrict yourself to something manageable, because there's too many variables. So you're like, okay, well, what if this was 0? What if these two are equal? What if we made this one? And the reason you've got an hour and a half to do this, because if you've seen the solution, you can probably do it in 10 minutes. Yeah. But obviously, if someone tells you,
I could definitely do that in 10 minutes.
If someone told you what to, if I just said set A, B, and C to be these 3 things, you'd have got the answer pretty quick. But the point is, I think, to me at least, the reason you're getting that hour and a half is you've just got to try, and begin to spot things that come out. That's how it felt to me when I was trying to do it. Was just keep trying things until you get somewhere, and then eventually you will hopefully get somewhere in the time limit.
That is amazing. And just before we end the video, if I can, because a lot of my audience would potentially be interested in applying to Oxford to study maths, physics. Let's say if they wanted to study maths, what are the top tips that you would give for anyone to get into Oxford and Cambridge?
Oh God. Okay. Yeah. No. Very good. Okay. I'm gonna give you the three. I'm going to give you three tips. Okay.
Perfect, yeah.
First one is really obvious, and it's going to sound almost silly for me to say it, but it's important to stress. Top tip to get into Oxford or Cambridge is to apply in the first place. And the reason I say this is it's really easy to convince yourself that you're not good enough, that you have no chance, to listen to the voices in your own head or maybe the voices around you telling you. If you are predicted the grades, right, you obviously have to be predicted the A stars, the A's that we want, right? We can't do anything about that. As long as you're predicted the grades, please apply and let us as the admissions tutors make that decision. Because otherwise, if you decide not to apply, you have made the decision for us and we may have made a very different decision. So that's my first tip. My second tip is to basically absorb as much maths, physics, engineering, whatever you're applying for, absorb as much of your subject as you can. And what I mean by that is don't just rely on what you're learning at school. Like, watch YouTube videos, right? Watch me talk about maths. Watch Celio talking about physics. I went blank then.
Temperature.
Watch, temperature. But like it's not because we are going to obviously test you on that, because we're not. I will not expect you to know any of this more advanced university stuff. But the more time you spend around mathematicians, physicists, engineers, the more you begin to think like a mathematician, physicist, engineer. So just like being aware of and like exposing yourself to all of these different ideas helps you to think more like the person in that subject. And then my final tip is basically to, I would say for maths in particular, is to have a go at the type of problem we've just been doing. So this is a really good example of the kind of thing we're looking for in a mathematician, in the sense of none of the maths that we needed to solve that was hard. It was like rationalizing, algebra, expanding stuff, polynomials. It's nothing beyond A level.
Do you think any of that stuff, or like, and kind of talking through that problem potentially is like good interview practice?
It's
like,
perfect interview practice, because the whole point of this question is there is no obvious way to solve it. You quite literally just have to keep throwing things at it until you get somewhere, right? It's almost like having a big metal door or a brick wall, which is the problem, and you're just like hacking away until you get a tiny little crack, right? And, we got a couple of cracks early, and then we seem to hit the sturdier part of the wall for a good hour or so. And then, with a little bit of a nudge from me, we figured out that setting these two things to be equal, it was worth a try. We didn't know it would be, but it ended up actually being the key to unlocking the problem. So like that's actually exactly what a hard university level maths problem looks like. You will not know what to do initially, and you need to have that tenacity and that determination, that motivation to just throw everything at it and learn those tricks and techniques to which ones are going to help, which ones aren't. So I think doing this kind of problem, as difficult as they are, and they are difficult, like I will admit that was a pretty tough problem. So, and I'm sure you would agree. I think it's not that we're expecting you to get a solution, and you shouldn't expect that of yourself, but it's really good practice to go through the process of not knowing what to do, but slowly, like it might take you a week, but you just keep trying bits until you kind of get through it. And I think it's super rewarding when you do as well.
Fantastic. Thank you so much. And what you should definitely do next is check out Tom's video in which he tried out the International Physics Olympiad. So you absolutely need to have a click at this video right over here. Click.